All right, so now we have moved to one of the biggest tests we talk about during our Look at Infinite series. This is the ratio test. It is a buckle in and let's figure this out. We need this in our toolbox kind of a lesson. So let's establish first what it is. And then in a separate video, we will do some more examples just to see how it works. We're going to let the sum of the a sub n's be a series of positive terms. Yes, we've let negative terms in, but this test works with series of positive terms. Suppose that rho, it looks like a P, but it's the Greek letter rho, and it's pronounced Rho is the limit as n approaches infinity of a sub n plus 1 over a sub n. Then the series converges if rho is less than 1 and diverges if rho is greater than 1. The test is inconclusive if rho equals 1. So why do we call it rho? Why is this a rho? Because it makes the sound and that makes us think about series that we've studied before. When you look at the n plus 1th term over the nth term, and that happens to be some ratio r, well, what other kind of series do we know where if rho is less than 1, we're okay, and if rho is greater than 1, we're not okay? This takes us back to our look at geometric series. And what the ratio test does in quite the powerful way is it says, if you squint at infinity, if you squint, and the series looks like it's geometric, then we can treat it like it's geometric. If this limit actually goes somewhere and it's pretty much geometric once you get to infinity, we can treat it like it's geometric. So let's play the game. Does it converge? So does it converge? Let's do n squared over 2 to the n. Does it converge? So we can figure out the limit of the nth term. That goes to 0. That's great because it means that there's a chance that this converges. So does this converge? Well, we'll use the ratio test. Rho is the limit as n approaches infinity of the n plus 1th term divided by the nth term. Well, the n plus 1th term and the nth term are both fractions, so we'll do the multiply by a reciprocal thing. The n plus 1th term looks like this, and the nth term looks like that. Well, this simplifies by algebra, and then we think about what's happening here. This is an n squared blah, blah, blah. That's an n squared. So this has a limit of 1. And so rho is 1/2, which is less than 1. And so this series converges by the ratio test. Converges by the ratio test. Does it converge? Oh, yeah. Does it converge? Take a moment, Figure out rho. The n plus 1th term divided by the nth term. And then we think about what happens. This is algebra. What happens here? How does that simplify? Well, I hope you see that n plus 1 is the factor remaining in the denominator. So what happens, limited infinity of 3 over n plus 1? Well, that goes to 0. And 0 is most definitely less than 1. And so this series converges by the ratio test. One more. Nope, not yet. One more. Does it converge? Think about what happens. What does the n plus 1th term look like? What does the nth term look like? Well, dividing by the nth term is easy. The n plus 1th term, not too hard to figure out down here. Up here, it's a little bit trickier. What happens here? What happens here? Well, we know that the n and the n plus 1 factorial leave an n plus 1 behind. N factorial and n plus 1 factorial leave an n plus 1 behind. What happens here? Well, this is 2n plus 2, 2n plus 1, 2n, 2n minus 1. This is 2n, 2n minus 1, all the way down, all the way down. So what's left here is 2n plus 2 times 2n plus 1. So we ask ourselves, the limit at infinity of 4n squared blah 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 over n squared blah blah blah. That's 4. 4 is bigger than 1. This series diverges by the ratio test. In each scenario, we take the limit at infinity of a ratio of terms, and we look to see, is it basically geometric when you get to infinity? In all 3 cases, our answer was yes, and we just compared, are the terms getting bigger or are the terms getting smaller? That's what this whole deal is, bigger than 1, less than 1. Hopefully this is helpful. I'm about to record a screencast with further examples in case those examples would be helpful.